Okay. The last pure diagramming technique we'll cover is what is called the data flow diagram, or DFD. Data flow diagrams essentially show how data moves around some kind of system. Usually there are computer systems, but that's not always true. DFDs can also be used to show like how paper documents flow around an organization. They can show how data is transferred from one part of an organization to another part, that kind of thing. The only requirement is that it illustrate how data flows, just as the name implies. I'm also going to mention before we actually start looking at the diagrams themselves that we're going to be using a particular type of notation for our DFDs. For some reason, this type of diagram has a lot of different ways of doing them. We'll be using the Jordan-DeMarco data flow diagram notation. There's a lot of information online about DFDs in general, and Jordan-DeMarco diagrams specifically. I'll encourage you to take a look at them someday when you have time. It's not super important. Okay, so let's first take a look at the components of a DFD. The first building block is the process, and processes are represented by labeled circles. They look like this. Processes are where all the work gets done in data flow diagrams. And accordingly, they tend to have verb phrases as labels. Like this one is called the view user profile. The next major component is the input or output. And they are represented by labeled rectangles like this. The example here is user, and it might seem a bit odd to consider a user to be an input or an output. I'll agree with you there. But here the focus is really on data. So we can consider a user to be a source of data, and that's fine for this type of data modeling. The next piece is the data store, and they are represented by two horizontal lines with a label of some kind in between them, and they look like this. This one is labeled database, and that's an extremely common type of data store. But data stores can represent anything that holds data. So your computer's hard drive or your filing cabinet, they can also be data stores. We're going to stick with these three major shapes for our discussion today. But as with any flow model, we need to have arrows connecting them. And in DFDs, every single one of those arrows needs to be labeled. The arrows need a description for the data that is being transferred from one shape to the next, and they look like this. Okay, and so let's go ahead and put an example together and show you that. All right, beautiful. Okay, now before we review what this diagram means, I'm going to caution you. Data flow diagrams do not show the sequence of activities. They merely show you what processes flow which data from inputs to data stores and then back out again to the outputs. Good. So let's examine this DFD. First, in the top left corner, we have an input or output box for the user. And we understand intuitively that this is some user of the system. Below the user, we have two processes. The first is the process view user profile, and the second is the update user profile function. Then below those two process bubbles, we have a data store called database, and we have arrows or flows connecting the input or output to the processes, and another set connecting the processes to the data store. There are more pieces to the right, but we'll come back to those in a minute. All right, so what can we learn from this diagram? Well, let's look at the left process first, view user profile. This process takes data from the database and conveys it to the user. And that makes sense. When you go to a website that you're registered on, you can sometimes choose to view your own user profile. And when that happens, the website gets your user profile information from its database and conveys it to you. Let's look at the next process, update user profile. In this case, user information is flowing from the user through the update user profile process and being stored in the database. And this is, again, pretty intuitive because we do this ourselves pretty regularly on websites and other systems. So here we have a little illustration of how user profiles are viewed and updated for this particular system that the diagram models. Now, let's take a look at the other process and data store and see what they're about. All right, so here we have a process, extract user details, which takes user information from a different database. Maybe it's a different database within the organization, or maybe it's some external data. And it flows those details to the update user profile process, which in turn stores them in the database. Okay, I included this additional process because it illustrates an important point. Not all systems in use today have a user interface. Some systems run continually or periodically to perform various tasks, and that's probably what we have here. Some program is running somewhere that extracts the user information and feeds it over to the other system, which stores it in the database. That right there, that's the entire foundation of data flow diagrams. They might look a little intimidating at first, but all you need to know are what a few shapes are and what the rules are, and you can master them pretty quickly. We have the processes that do work. We have data stores that, they store data. We have inputs and outputs where data comes from or goes to. And we have the arrows that indicate which data is flowing where. Okay, I lied. There is one additional rule, and that's that data cannot flow on its own. It can't flow from a data store directly to another data store or from a data store to an input or output. No, it has to be driven by a process. There has to be an intermediate process, since processes are where all the action is performed. Notice in this diagram, looking back at this, that all the data moving around is through the three processes. You don't see any data moving directly between the data stores or between the data stores and the user. That is by design. Think of processes as things that either accept data from an input or send data to an output or put data in a data store or retrieve data from a data store or just do miscellaneous other processing. That's really what processes do. I'll recommend a couple other things to help you out as you're starting to work with DFDs. First of all, label everything. Everything needs to be labeled. This is particularly important with DFDs because missing labels will seriously reduce the value of the diagram, probably to close to zero. So everything needs a label, whether it's an input or output or a process or a data store or a flow, everything. Another tip is, and this is a really good idea, keep DFDs simple. These can easily expand to be enormous wall-sized diagrams, but just try to keep them small. A good rule of thumb is to have 10 or fewer processes, 10 or fewer of those big circles in a single diagram. Otherwise, they just get really unwieldy and difficult to follow, both for your stakeholders and even for you, the person that's making the diagram. So just keep those simple. Okay, so I think that's about 5 different types of diagrams. Enough for now. Let's go ahead and move on to modeling.